So in this video we are looking at the Nyquist stability criterion. So this question says that the Nyquist plot for open loop transfer function of a unity negative feedback system is shown in the figure. So this is the Nyquist plot for a unity negative feedback system G of S. So now it says that G of S has no pole in the right half of S plane. G of S has no pole in the right half of S plane. So means G of S open loop transfer function has no pole in the right half of S plane. So it means that the value of P is 0. Because as per our Nyquist stability criterion, n is equal to P minus Z, and what does P denotes? P denotes the number of poles in the right half of S plane of the open loop transfer function. So here it is given that the G of S, which is the open loop transfer function, has no pole in the right half of S plane. So P is 0. Now n is the number of encirclements of the critical point. Critical point is minus 1 plus j0. So this is the critical point. Now there are one clockwise encirclement and one anti-clockwise encirclement. So one clockwise encirclement and one anti-clockwise encirclement. So the overall value of n, the number of encirclements, is 0 because one clockwise and one anti-clockwise will cancel each other. So n is 0, P is equal to 0. It means that Z is equal to 0 because if you put here the value of Z is 0. So if Z is 0, Z denotes the number of poles in the right half of S plane of the closed loop transfer function. So there are no poles in the right half of S plane of the closed loop transfer function. So there will be no roots in the right half of S plane of characteristic equation. So the correct option is option A. So this is a very easy question and we can easily solve it from the Nyquist stability criterion. Thank you and best of luck for your exam.